Hello and welcome to another video. Today we have a B550M ITX AC on our bench from ASRock. Very small, nice board. This is AM5 ready. And the problem, what the viewer said, is that this sometimes doesn't want to boot with different memory configurations. So at the beginning he only had problems with 2 memory sticks when using them, and by now he said it sometimes doesn't want to boot at all. So we will have to find out what is happening with this board, why it doesn't want to boot sometimes, or maybe doesn't want to boot at all currently regarding RAM. So I don't think that we are going to have any short circuits on here. So we won't need to measure any resistances because this is supposed to react to a power button and get somewhere. So let's plug the power into here and get a stick of RAM into here. So I'm using a 3100, that definitely should be supported on this. Then we are also going to be taking the post analyzer of the DRAM, so we do know how this board will react or if there's anything happening. And let's see if we have a space where we can connect our PCIe postcard to, if we have a TPM header or something similar somewhere. So there's no TPM header on this, so not a possibility to connect the PCIe postcard, but let's see then what we can see if we now get passive power consumption. So let's see now. About 100 milliamps. Okay, that looks fine. Nothing special. Let's see. Press of the power button. We do have a reaction, and we do have cycling postcodes. C0 currently. And we do have cycling power consumption, as you can see. 3 amps, 1.5 AF. This looks like it is supposed to be booting right now. Yeah, CPU gets hot. Okay. Yeah, okay. This seems to be booting. Let's get a CPU into here, a GPU into here. So we have dedicated output. And let's also put somewhat of a cooler onto here, so we don't overheat instantly. So let's see again. Our current measurement will be will be telling us what is happening with this. Let's get a postcode also, the post screen also into here, and let's see now. So let's see now together. 3 amps, 4 amps, and this picture. Okay, so far it just works fine. Okay, let's turn it off. Let's then get a second stick of RAM into here. So a second stick of RAM, let's see once again. So again, power consumption 2.5 amps. And now we're kind of stuck. 2.5 amps. And doesn't want to move away from them. The only increase that you can see, the very small one, is just from the CPU heating up and the resistance getting higher in itself. Okay, very interesting. So, let's then... Okay, it reacts to the power button. Let's now see if we can boot with one stick. So let's get the post screen smaller. So we first had a boot with the left stick in, and then we didn't have a boot with the right stick in. So let's remove the left one again, see if we get a boot with only the right one. So 2.5 amps. And nothing. Okay. Let's swap the actual sticks. And now again. Now with a different stick of RAM in there. But no boot. So we do have a problem with the right memory channel. So, and just to be sure, we're also going to be testing the other RAM stick in the first slot, just to see that that one works. 2.5, 2.6, yeah, you can instantly see the change in current, that this is going to be booting now. So, the current situation is left one is working, right one isn't working. Okay. So, what we can do. The first most easy thing is to clean the socket. How do I do that? I take a good amount of IPA either you take it on a Q-tip, or what I also do is I have a spray bottle where I just put IPA in there, and I just put a lot of it onto the DIMM itself. So what I'm focusing on is putting a lot on there, on both sides, and then I'm just going to be running it in and out a couple of times, so that we just have a lot of liquid IPA on there. And we try to rub these contacts clean again in order to see if this will help. So just do this a bunch of times, and this will restore some sort of the connection if the connection is broken because of dirt. So a couple of back and forth. Let's now see. Do it once more. And 2.5 amps, but no change. So this isn't a dirt issue as far as it seems. So next in line, we will have to get a data line tester for DDR in here. You could also now try to like blow it out with compressed air or anything, but I'm pretty sure it's not a problem regarding actual contact because of like dirty pads or dirty pins. So let's get a DDR4 data line tester and compare the two sockets if you can see a difference. So for that, let's remove the cooler so it's easier, and also the GPU here. So let's see now. Data line tester. And this is the working one. And we can see, if we go down, only a few ones are missing. But those are, I've marked those that are most of the time missing. Except that one, that is in this case is not missing. But everything looks fine. So let's now go into the other slot and see. So let's see now. But, oh yeah, I can see one. Oh yeah. Right. No. Right there. One missing LED, A7. Huh. Well then, we have a broken track then. A7 seems to be just a data line. And I can see another one, the upper one, A14, I think this says. Right there. Interesting. So we have two missing ones. So we actually have missing data lines here. So this can never boot. And I also done the wiggle test when wiggling the stick around itself. There wasn't a connection being established. So it seems like we either have a scratch somewhere on this side or on the other side. So for that, we probably have to go over to the microscope and have a good look at the backside of the board and from the RAM channels. So let me do that, and if I can find anything interesting, I will probably get you back into here. So I wasn't able to find anything instantly on the board looking wrong under the microscope. So looking at the backside of the DDR tester, you can see A7 is supposed to be pin 211. And with that, we can then find out what will be missing here. Or we can somewhat trace where that pin is supposed to be. And the other one is, I think, A17, which should be pin 65. So it seems to be this pin right here. You can see 211 MB-ADD7. This is a direct data pin that connects to the edge right there. And it's a little bit above the middle point right here. So this pin is supposed to not have any contact anymore to there. Interesting. So this is the first one, and the other one was supposed to be number 65, MB-ADD12. It's very close to that one. Yeah, you can see there's 65, there's 211, and it's very close also here. So this could be torn traces, but this also could be a dead socket. So nothing left but to go under the microscope and try to find this line. and then see if we can find any problems, because there's no components at all between that. Between the CPU and the DDR, the data lines are a direct connection. There's not even capacitors in between like for PCIe. So yeah, we will have to see. So after fiddling around a little bit, have a good look at this. We can now see A7 right there lit up and A17 also. And what I've done, all I've done is resetting the CPU and cleaning. So yeah, I went way too deep instantly, because I was looking already to find the traces on the backside or the front side, and I wasn't seeing them. They seem to be running in an inner layer, which is really unfortunate, because you wouldn't be able to repair them. But it seems like that the socket has actually gone too dirty. What can happen is thermal paste, for especially, that can get into there. What I very often do then is I take the IPA spray bottle again. With this you can get very deeply into the sockets, and then I take a toothbrush and try to get as deeply as I can into there to clean that, to make sure that this problem isn't going to come back and isn't going to affect any other ones. And there's a lot of IPA in here. And then what I like to do is I like to take compressed air actually. I do have a compressor in my room that I can use. So the compressor that I have is completely overkill for this. This thing has 10 bars at fully charged. So it's really strong. And what I like to do is I like to get a lot of IPA and then blow it out carefully. Not directly with the 10 bars, but like, you know, you get the gist of it. I'm going to mute myself because it's going to be really loud. And now we should have a nice and clean socket. So let's try this again to build this system up and try 2 sticks of RAM. So let's see now, getting our power supply, power consumption in here again. And let's press the power button here. 2.5 amps. Let's see. Is it going to change? And still nothing? Was this just a fluke? Nah, really? No way. Is there another issue here? Oh, we're stuck at 2.6 amps. That is very bad to see. Let's see if we boot with a single stick. Still. Yeah, we are booting with a single stick. Okay, let's try then with a single stick in the right one, if this doesn't want to work. And yes, stuck power consumption. So was that just a red herring? Man, this board bamboozled me. Well, back to square one again. So, it doesn't want to boot on the right one. So then, let's try again. Just to be sure, we're going to see for the data line tester once more. And now all of a sudden A7 has no contact again. Interesting, and A17. Let me do a couple of reseatings. And now we have contact with A7 and A17. So I think this might be a partially short socket. If this now works, this might be a partially dead socket. Interesting. So depending on how you're putting this in, does it boot now? Nope, no boot. Very, very interesting. Let me tinker a little bit with this, with reseating the CPU and the RAM, and seeing if at some point I can get a boot from this. And now we have a boot actually out of the right stick. Let's see if I can get it to boot with both of them and go into the BIOS. Because it really seems like we just have a dead socket right here, where it sometimes works and sometimes it does not work. Which is really an awful behavior to diagnose and to test. So let's get actually into the BIOS, so I can show you both of the sticks working. So there we are, both sticks are recognized. So what can I say to this one? This is sadly a dead end for me, because I cannot replace CPU sockets, and I can definitely see that this is a problem with it's probably the socket, because I've done basically what I can to the DRAM socket, and I don't think it's a problem with the DRAM socket itself. I will be trying something. What we can try is find the A7 pin, the number 211, and probe that one and probe the actual socket and see if we get any change when I try to wiggle around the slot. That we can still do to verify that it's the CPU or the RAM socket. So we definitely know there's no missing components, no broken components. It's either the RAM socket or it's the socket for the CPU, one of which. Let's see if we can find out which of those are broken. So currently you can see I'm probing one of the points. This should be A7, and when I go onto the socket, I can get A7 to work. And when flipping the CPU socket back and forth, I get varying results whether I have contact or not. So when I get the CPU socket into a position where it has contact, I can move the RAM stick around a lot and it doesn't change. Let me show you that in the overview. So if I have the connection right here, the beep is going to be annoying, I know, but this is for the purpose of the video. It's now inserted. I'm now removing the RAM stick and there's no change. And only with the change of the socket something happens. It is basically almost there. Like, I wouldn't think this making too many problems, to be honest. Like, it seems like it should work, but it just does not. Let's do that also with with A17. So the 65th pin. I want to do the same thing and test that, if that yields any different results. And this also has a pad on the tester right here. So I'm probing a pad on the tester that is labeled A17, and then I'm going into the board view and seeing for that exact pad and going into the socket. So, and I'm now probing A12, not A17, I misread that, and that has basically the same behavior. So I definitely get a contact when trying to get into there. So I really cannot tell if it's the CPU that has the problem or the socket. So I can show you as well on this one. There is A12 written on here. Right there, it's A12 is pin 65, what we saw. And on this side, there's probe points that I was using right here. And there's A12 like there. And those probe points I was using. And I was probing the pins inside the socket, and I was just using a board view to match those. And yeah, I really don't know what the problem is. I would say it's probably the CPU socket, pretty surely, because on the RAM sockets are very sturdy. They can handle a lot of abuse, but the CPU sockets can die fairly quickly. So I think that this board probably needs at least a reflow, maybe probably even a socket replacement to work reliably. And yeah, and I'm going to be using the time that I have to announce these here. These are the bigger version for the INA260 that I'm always using on my channel. You probably are used to seeing this one. And this is now the new and improved design that now has red and black and has the big screen using, and now it's an actual square box and not like this one. And the contents is still the same with debug LEDs with the INA260 right there, the RP2040. And yeah, this is still the design by me. If you haven't seen the video on how to measure power consumption, and I'm now offering these. These ones were the first version. If you've seen the video about, if you've seen the community post that I've made, this was the first version that I made. This is in green with a small LCD. I still also have some in purple, but most people were interested in the big screen version instead of this one, and also in black, so I made exactly that, big versions in black with PLA. And there's a community post about how to acquire these and also all of the information about them. So if you're interested, check that out on my community page. That link is also linked in the video description. And yeah, I hope you learned something. I hope you learned on how to diagnose when you have DRAM issues, what you can do with cleaning both of these sockets and then using this DDR tester that is actually quite powerful and has a lot more than just these LEDs, where you can manually test a lot of things with these debug ones, and actually also the table at the back. So yeah, thank you very much for watching. I hope you enjoyed this video, even though it's not a proper fix, but I hope you learned something. All of my tools, as always, are linked in the video description. Thank you very much, and goodbye.